these companies during that work. And since then, we've got to know them a little better, and we've actually got some stuff in store for you at our exercise. So I want to introduce a group of folks to you. These are from a variety of companies that have kind of formed a consortium to solve some really difficult problems out there. First of all, I want to bring up Kevin Lytle. Kevin is the CTO of a company called Syllego. They are essentially the system architects for these solutions. And then I'd like to bring up David Sprinzen. He's the VP of Partnerships for Vantiq. So Vantiq offers a pretty unique platform. I think you'll agree when you see. What they do is they ingest a whole bunch of IoT and other information and make sense of it, and then produce an output that's useful. And so they can drive generative AI, they can drive all kinds of activities that might help you respond in an emergency incident faster than individuals could do that. And then Steven Cercone, who's from Safe Cities Global. And so instead of talking about kind of just general theoretical, we could do this, we could do that, we're going to actually take you through some examples of how this technology partnership can actually be applied to some problems making our cities safer. And then Brad Jens is VP of Sales and Marketing from Contec. So Contec is a company I had not heard of. They make a variety of different hardware products, and I was just telling them earlier, after we learned about this consortium and I went to the Contec website, I'm like, oh wow, we could use that, we could use that, we could use that. So just a huge win for us, at least as far as how we can use these folks in I can't even calculate how many ways they could maybe help us in future products or projects. So really their goal tonight is to talk to you about some real examples that we might face out in the real world, integrating IoT into something that makes sense, right? The promise of IoT has always been to get all these sensors out and then we know what to do. And really what we've seen so far is we get a bunch of noise. And so how do we get compute out at the edge? How do we make sense of these sensors? How do we apply some logic to make ours, in some of these concrete examples, to make our cities safer? And from the TAMU side of things and the ITEC side of things, how do we see this fitting into disaster scenarios, right? How can we use this combination of assets to create potentially new solutions that solve some of the problems we heard Dan Cotter earlier this morning, or this afternoon, talking about out there in the real world. Okay, so guys, take it away. Plugged in. I just don't know about this. Got big enough. There's plenty of food. Like home, back to your well, maybe we kick these off with saying, go back to slide. Hi everybody, Kevin Lytle, CTO of Syllego. About 5 years ago, Michael and I met. We were working in defense and AI space, building consortiums for a very large global manufacturing company. Can you speak into the microphone? Sorry, thank you. I didn't want to be too loud. Normally am. So what we found was the critical piece
was that the compute manufacturing hardware that they had lousy software. Software players had great software and just picked the hardware that their price point seemed to be. These were the fine-tuned this solution set. So what we did was we started building a consortium around public safety, disaster response, critical infrastructure, base security, disposable sensing systems for pre-deployment for the military, but also for disaster response. And from that, these partners have all been with us from the beginning. And we started to address specifically how do we get mission critical data collection into the field at a price that can be afforded, an energy budget that makes sense, and a sustainability cost that makes sense. So good enough data collection to get the mission done today, justify the spend, and then start iterating on more improved and finer tuned systems once you've proven that that spend is worthwhile. So we're doing what we call see, hear, taste, smell, and touch in our sensing platforms: water, air data, noise, VOC, vision systems. But doing it at a price point where at an intersection cost maybe we're in the $10,000 to $15,000 cost instead of $25,000 to $50,000. Is it as good as that $50,000 system? Perhaps, but is it affordable at a wider scale? The key thing for us is that hardware is important, but what's really important is the software. How do we get data from all these systems, the dozens of systems each of you are working, without having to directly address existing code, existing libraries, existing databases, disrupting those systems? How do we make those connections seamless and true real time? And I think when we've done speaking today, you'll see that we have a set of tools. These are not canned products. They are your solutions designed for you from scratch very quickly at a reasonable price. And we can go to see on simple systems and start. But we really need to define a mission for us. We don't have your mission defined. And so our job is to be your advocates, bringing technology to you. We'll pick the right hardware. We don't own the hardware. You can pick the right hardware, the right software tools, and bring it to your mission based on your needs. So that's kind of what we're here to at Interop. But also, we are working with a lot of people here, and it's been resonating. So if you guys have anything that you wish to bring to us, we're happy to speak to you about it.
Okay. Nope. All right. Yeah, my name is David Sprinzen. I'm VP of Partnerships at a company called Vantiq. We're part of the consortium that Kevin at the Syllego mentioned. We're kind of the software glue, so to speak, that puts a lot of it together and makes it work. And so what Vantiq is doing is we're an application platform, so we're helping build and deploy application workloads, but we kind of focus on a special type of application. We look for applications that are leveraging real-time data out on the edge in the real world and converting all of those different data sources into the kinds of actions, the orchestration of what you do when something is going on. And so we're particularly focused on when there's something going on, an event of interest, a natural disaster, a car crash detected, all the above, and I'll go into some of those examples. We're helping build out the integration logic to pull that data in, the rules and the things that you're looking for. They can tell you effectively what is the situation of interest. How do you build that situational awareness of what's happening? We're building the integrated decision making. So a big part of what we focus on is in these spaces where there's lots of different decisions being made, some of which you can automate using technology, a lot of which you need humans in the loop to be involved in those decisions. How can you, with software, be able to create the ways in which you're orchestrating those decisions? And then the last piece, which is often the most important, is what do you do? Like, what are the ways in which you're leveraging data and AI insights into accurate and precise outcomes, or to automation cycles, notifications, communications, coordination between different agencies. So being able to kind of look at that big picture and say, well, we can do this in an application platform where we're not having to have, multi-months of development involved in getting those systems built. We're usually involved, or we're usually able to work with partners on developing these solutions in a matter of 1 or 2 weeks. So we're trying to make it where that speed to create that the outcomes based on real-time data is much faster. You can start iterating on the kinds of solutions you can build and the ways in which you're leveraging those insights. I'll take a second here and go into a project that we're doing that I think is probably, to the best of my knowledge, the most comprehensive disaster management solution currently being developed in the world. So this is in the country of Japan, sponsored by the Japanese government, being implemented by NTT Data in Japan. It is a countrywide disaster management system. We're connecting to sensor data. It's looking for floods, looking for earthquakes, extreme weather. We're connecting to all of the various weather APIs. We're connecting to satellite imagery. We're also looking for social media cues and keyword search against all social media. So effectively, we have this real-time intelligence, right? Situational awareness across all of these different domains to say, how can we detect the moment something is happening? And then when something happens, when there is a flood, for example, we can determine exactly the area of impact. And we're using AI to create, in this case, we're actually using generative AI to be able to create alerts to individuals in that area that are personalized to their location. And so instead of it being a one-size-fits-all alert structure, we can actually batch at scale in real time as a personalized message to each of the individuals that are impacted with even, for example, evacuation routes that tell them exactly where to go. So that's phase 1 of that project. Over time, they're going to start looking how that's integrated into the kind of full disaster management suite of domains of different agencies involved. So police, EMT, city operations, traffic management, and traffic flow. So they're really trying to make this kind of the big picture integration framework for managing natural disaster. I think that's a taste of kind of the kinds of systems that we're working on developing, and our focus is making it so that these systems aren't costly, and maybe more importantly that they're even feasible. But historically, this has been almost impossible problem to attack with kind of traditional applications and big data oriented models. I'll pass it on to Steve Cercone over here, who's working with us on the advising and brings a background in public safety that he can help us figure out exactly how to make these systems effective. Okay, well, I might have to sort of backtrack a little bit. Let's see. To jump ahead. I'll quickly talk to this. Kevin mentioned this, but the idea of what we're doing here is connecting a bunch of different companies into, we're calling it this consortium, IS3, Intelligence for Safety, Security, and Sustainability. And the IS3 consortium is a grouping of companies with that mission of how can we be better at building intelligence systems that deliver on the promise of safety, security, and sustainability. And so it's a combination of hardware companies, sensor companies, AI companies, software companies, and we all have our different strengths. And we're creating this integrated stack that can tackle all of these problems collectively instead of it just doing one problem at a time with one solution vendor. Yeah, I don't have the slide in here, so. It's okay. Let's keep it. I don't think the slides are our friend today.
Steve Cercone. Thank you, David. And
I live in California, based in California. I am the president of Safe Cities Global, which is a consulting firm that brings technology to state and local and federal government. I work with companies like Vantiq, Contec, and Syllego to advise them on how the public safety world fits, or the technology fits into the public safety world. I did almost 30 years of law enforcement. I finished as a police chief in California. I am on the Vantiq board of advisors. Vantiq, and the reason I am doing that is because they're generative AI technology that is changing the world, and we see this all around. We see this everywhere now. What AI is doing, not just in government public safety, but there were, going back in my career, my police career, and then even in the technology world since I retired as police chief, there have been a few times where I got really excited, and it's kind of funny because the first times I got excited, wow, what a big deal that is! You can run plates, you don't have to get on the radio, you can actually talk. Back in the '80s, we were texting before there was texting, and it was really. And then DNA analysis came up, DNA to catch some really, really bad people. That was exciting. And even going from the over handgun, yes, I actually got a revolver. That was a big deal. But fast forward to all the technology we've seen over the last few years, decades, in AI and public safety now. What's exciting to me, it really is the most exciting time to me, because it means changing of lives and saving of lives, because it speeds up the process, it speeds up the efficiency of public safety. And I'm talking about law enforcement, from the crime prevention or accident prevention technologies that it improves, to the 911 dispatch center, with the communication now with AI is making allowing the call taker from the exciting 911 call into the call taker, screening on the phone, getting accurate information with AI into the dispatcher, so that they can send it out there to the police car officers, to the fire department or the medics. And then that also goes back to the ER now, like that, to the emergency rooms. And of course, investigation AI is really making investigations of criminals more efficient and faster. I gave a talk in London not that long ago about, wanted to know about police work in America. Well, we have it all, right? And one thing I said, it's really, really hard to be a cop these days. So it's hard to be do any public service. But I truly believe it's harder to be a criminal and because no matter where we go these days, technology is going to track that individual, whether it's the video cameras or the surveillance system outside of a house, business, or ATM machine video, or the GPS, all the suspects, all the criminals, very phones. This has transformed everything so that it's really hard to hide these days. And AI is now making this just speeding up the process and ultimately get back to saving lives. And that's why I advise companies like Vantiq and allow the public safety world to know about this new technology, because there's so much. People really have to be educated.
All right, so Brad Jens, I'm the Vice President of Sales and Marketing with Contec. So they started the meeting off by saying they didn't know much about Contec, and we looked up our website. Wow, they have a lot of stuff. So before today, anybody in the room ever heard of Contec? Raise your hand. Besides the Contec team. Nobody. I think I'll probably lose that. Oh, we got one back there. Woo. How would you like to be the Vice President of Marketing where no one? Off my title. So we're a 42-year-old company that's part of an 80-year-old company that actually invented the industrial PC. How many of you have ever been into the airport scanner machines when you have to hold your hands up? Contact products in the top of all of those. How many of you have taken a paint swatch to Lowe's or Home Depot and said, hey, I need to match this color in my kitchen, and that's made by a company called X-Rite, and they use Contec for the way to do it. So we're a lot of places that you've never heard of, data acquisition and other industrial products. How many people remember the IoT revolution that was supposed to change everything? And it kind of petered out for a multitude of reasons, mainly because there's a lot of siloed data and different companies were trying to accomplish different things. There's different protocols, there's different software packages. We had to spend $3 to $5 of engineering time to generate $1 of revenue because of all the complexity and different silos of information. And so now when we see this new AI revolution and all the data that's coming across, we've learned some good lessons. And one of those is no one hardware company can do everything. And so we manufacture over 800 products, and some work, some don't. And we created a new model from the hardware perspective where we say, yes, we're a manufacturer, we can make things, but we're also an integrator. So we can buy commercially available off-the-shelf parts and put those together to meet a customer's needs. But we can also resell other people's products that have best-in-class solutions. So even as a manufacturer, we're looking at our approach to the market as being as agnostic, because we want to put together solutions that really fit our customers' needs. And now that we have a consortium like this, where we've got the software stack, the sensors, the cameras, the hardware, all the pieces can be aggregated by our company and be ready to deploy to market, real time. We're working with these guys and you and learning over the next couple of days. We were at an event last week, and there was one of these economists that had met with the buyers, pyramid groups nationwide, and they're looking at the budgets. Over the next 10 years, they're projected to have a $1 trillion shortfall in spending availability to the needs that everyone submitted. Says, hey, here's our journey and where we want to go over the next 10 years. And they also said there would be a 500% increase on electricity needed based on the current technology that's in the market right now. So what Kevin and the team have done is put together low power, low cost, I think almost disposable type hardware that we can put on the edge to really have a cost structure that allows us to achieve all of the goals that we want to do, from our edge to the edge to, all the way up to the data center. And the beauty is that piece that ties all that together and allows it to communicate back and forth and work all the way up that stack there. So couldn't be more excited to be part of this group and also to learn your needs over the next couple of days and share with you how we might accomplish those together.
I'd like to just say that back in May, we were invited to a conference with the Product Transportation Innovation Alliance. And the takeaway for us was everybody wants to sell you a 50 kilowatt system for $500,000 and for every intersection. And I asked the director, I said, how many nuclear power plants are you building this year? You can't afford the energy budget. I don't care how much good those systems bring. And that was what really kicked off this group. How do we deliver the right energy levels, the right performance, in the right places, the right time, for the right dollars? We need to tell us what you need, and being part of the this group and being invited to come and being in our company. All of us have gotten a tremendous education how to do this well. We knew we're on the right track. Thought leaders that are going to guide us to the solution. We're not trying to tell you what to do, we're trying to help you do what you need to do. That's what I think all of us here are focused on, that the power, the energy, and the cost issue is critical for us. So
I have a question. How many of you in the audience are familiar with the concept or the term edge computing and what that means? Okay, so maybe half. So obviously, I think you guys are all at least heard the term cloud computing, right? So edge computing is the trend that they're taking a lot of the things that made cloud computing so powerful, right? These serverless architectures where you're able to spin up and spin down workloads very, very quickly. The infrastructure is decoupled from the workloads that's running on it. Edge is the extension of the cloud out into the world, right? And so the idea is, how do we get the things that the cloud is particularly good at? How do we make the applications that we're starting to build and that are deployed at scale in the cloud, how do you get those to be running way closer to where the data and where the action is? And there's a number of reasons why you do that, right? Of course, performance and latency become the most obvious, but actually one of the biggest things that people are starting to talk about a lot is the privacy concern, right? And of course, anything that's like, talking about building AI that's out in cities, collecting data, you're going to have citizens with a gut reaction of, this is, big brother. This is people trying to track me against my will, know things about me. And one of the things that we've been pioneering and really educating the market around is you can build these systems to be non-identifying. So in many or most cases, we're not actually using anything that's recognizing who people are. And B, it's all transient inferencing. And that means that we're putting, for example, computer vision models that are looking for car crashes. We're doing this as an implementation in the city of Las Vegas right now as a group here. And we're running on cameras in intersections in the city of Las Vegas. We're looking for car crashes or any kind of vehicle incident. We're using computer vision to do that detection in real time. There's no data being stored or collected. It's purely just looking for a situation that needs to be addressed. And if there is something detected, then it actually triggers a secondary analysis that's able to look at the severity, if there's an injury, if they need to have a tow truck to come pick up the vehicle, if they need to reroute traffic. That's one of the things we're looking at now, is integrating directly into traffic control and into light management. So we're doing all of that on the edge with data in motion without having to store or almost no storage of data. And so we're trying to change the perception around the big data ideology. Everything is data to collect and store. Data doesn't actually matter. What matters is insights, what's happening, right? And if there is something happening, how do we effectively respond to that as it's going on? And how do we make sure that when it happens, all of the downstream agencies or actions that need to be triggered, how are they being integrated? But the data itself is transient. And so we've done a lot of work on trying to make these systems much more privacy secure. And it also decreases the potential attack vector when you're looking at people with malicious intent. So just a point to really emphasize on why the edge here is so important. And as a group, we're basically building a flexible and modular stack to run on very small edge devices or data centers or some potentially in the cloud, but being able to cover that entire compute landscape with applications and application logic that makes sense as to where it's running. Yeah, so one thing to mention is we'll be as a group over the next 2 days, and then a live demonstration on Thursday during the disaster city exercise. We'll be showcasing effectively a demonstration spun up in just the last 2 weeks. So we built it pretty quickly, but that's emphasizing the agility of our approach. It's integrating the digital twin that the TAMU and ITEC group have created to show the disaster city map and what's going on there. We're integrating with a number of things that digital twin is looking for, such as fires. And then we're also integrating with TAC and the location of TAC devices, being able to know based on the location of those devices, what do those individuals need to do? How are you communicating with them with location-based logic in real time? Is there anything you want to add to that?
Sure, I can just add a little context, I think. So is Dr. Towner? There it is, Dr. Tao from our visualization department. So he's been working on a project with NIST to create a digital twin of our disaster city, which where we'll be conducting the exercise. And his digital twin is multiplayer, so you can actually move around in the twin and see who else is there. That digital twin is now integrated with TAC. So on Thursday during the exercise, as people are moving around with their phones connected to TAC, if you look in TAC, you'll see icons moving around. When you look in, then you'll see the people moving around. And you can interact and see what type of people they are, whether it's fire, police, things like that. So after we were introduced to Vantiq and the whole team, we started working with them on this. And as they said, it's been a matter of a couple of weeks. They've now integrated with those. And so on Tuesday afternoon, we have a tour of the Bush Combat Development Center. And one of the things on the tour is called the Fusion Cell. And this is where at the combat center, what they do is test range where they can bring in autonomous vehicles and drones and all kinds of stuff. And the Fusion Cell is where you can bring all your data back and see it on a big giant video wall and understand how it's progressing, that type of thing. So we're going to use the Fusion Cell as a simulated DoD Tactical Operations Center for the exercise. So in this kind of exercise we're doing, it's a major sporting event. National folks are, senators, maybe the president, whatever is president, and we have a bit of a problem happens. And so I don't want to give away the story, but the military would be staged in such an event somewhere off-site. And so we're using this as the kind of the talk, and they're going to be pulling in information from TAC, pulling in information from the digital twin, and pulling in information from Vantiq. And so you'll see kind of like 3 different views of the world, right? 2 that are, one's very visual, one's kind of mappy looking, and one kind of takes that information and makes sense of it, and then recommends actions to be recognized as certain things happen, right? So sensors trigger and it recommends you might want to do this, right? It notices the number of people in a certain area. There's something going on here. You might want to take a look at this. So it helps the emergency management team to better. So that's going to be used on Thursday in the EOC, but on Tuesday, if you're doing the BCDC tour, you'll be able to see a snippet of that, a little preview of that in this Fusion Cell.
So we're quite interested in if you have any questions or comments on what we kind of say. Feel free to ask. We're really here to learn from you as much as we are to do what we're trying to do.
If you have a question, I have one. Yes. I've been working with private networks for almost 4 years and trying to do things like this for industries. And one of the things that I think it ties to what your guys are showing is the context, right? The context is the key that you have to have at first to define any solution that you're bringing. Do you guys foresee any systems that can bring this in a repeatable way, such as a kind of almost marketplace that you can pick and choose what you're going to use and apply, or only the way that your guys are saying to apply very fast, right?
Yeah, I'll talk just from the network.
Mike.
Sorry, I'll talk about from the network down. Data. So everything that we do is opted into the existing ecosystem, right? So if we're going to enhance the network, we're going to. It's supposed to be an open system. Those firewalls and the that's going to take some work. But we start with each layer and we attack that as we can. Start to build this knowledge base, especially within the state of Texas. We let Texas decide what that stack looks like, and we just repeat it over and over. Everybody agrees. They and it spreads. So no, at no point are we using the crowbar to force in a technology stack that doesn't, it's not.
Yeah, two kind of key points based on what you said. So one, I would say maybe marketplace isn't necessarily the right word, at least not at this point in time, but modularity or a composable suite of use cases, that's what we're targeting, right? And so whether or not it's a marketplace of vendors, it's more like here's a set of these composable use cases and you can kind of pick and choose and they're all effectively able to run on the same shared infrastructure using the same shared software stack. So composability is key here and a core tenet composability or modularity, right? You want these things to be highly flexible. And that means both flexible to how you're doing them, to what you're building, and also being able to spin them up, spin them down, change the sensors, change the AI. So by decoupling a lot of these things so that you're not creating effectively horizontal capabilities at the different layers of down from the infrastructure and sensor layer up to the use cases, the communication capabilities and modularity across those, then you can start tackling these problems in a very kind of mix and match style and approach. The second point, you mentioned context, and I gotta be careful because I can rabbit hole this real quick. Context is really, right? Because the context of when this sensor says this thing at this time, what's going on around it, who's involved, where people are, the policy, the history of that specific sensor, like all of that creates this kind of context space that you want to be able to leverage, and that will inform your understanding of that situational awareness of what's happening. And one thing that we've been focused on that is actually something that we didn't realize when we started this is generative AI is remarkably good at pulling context in real time. And so I'll try not to get into the technology too deep, but there's some generation, which means you can use generative AI to say, here's something that happened. Go look at this knowledge base and immediately in real time pull the relevant pieces of information that I might use to say, why is this happening? What is the context? What is the policy? What is the history of this device? You can kind of capture all of that, pull it in real time, and then start contextualizing or enhancing the context of what's going on. And that's something where you can effectively start creating systems that are self-learning because you can start just adding more and more material into this knowledge base, and it can start, as things are going on, retrieving what is needed and telling you what to do without having been explicitly trained to do that. So dynamic and self-learning, that's where these systems are going to get pretty soon here. And so we're working on that. And I think that's where probably the future of this technology is.
From a marketplace perspective, one of the things that we talked about was finding a host for a Vantiq instance and also getting some PhD students from and get communities together and start attacking problems and building a common set of tools that they can all share. So that as that knowledge grows, you can share it in the community. So not everybody's not starting from scratch, right? It's take this set of generic capabilities and then with decisions from your needs. Again, not from scratch, so it's something that can be repeated over and over again. Starts to grow, it becomes kind of a much more cohesive picture of sharing the same picture and the same tool set.
I have one more, Lytle. It's okay. Last year I was doing a 1-year program in MIT, and as part of the program, the last assignment was to present a startup, right? And we started to analyze things like this, and you mentioned lowering the cost of the devices in the edge, the computer and these things. And doing the roadmap, we found out, a new technology that's not that new, but analog computing for inference in images. Are you guys also using this kind of things to lower if the cost of computing per dollar per wattage, right?
Yeah, actually. So
We have partners here that, we specifically for what they're looking at. Jump is strapped to a atmosphere like a solar powered. Box and do it operation and get 30 frames for that. Animal, person, bicyclist on the roadway, fire, VOC detection in that box in that 30 to 50 watt range. Box the sale area of solar panel. So the goal is to have something that's extremely small, to have a very small amount of sale provide power. In those, there is no power, but in areas where we're tapping off other. We can't put 5 kilowatt servers on the vault. Under that number shop budget that we're trying to hit. And we're trying to do it where you were to have the system of 10,000, possibly as low as $5,000 for the system. That software, the radios, everything. Is it going to be as good as a Hanwha or some of these other systems? Not 40,000. So we get 3,000 or 4,000 of these on a rural roadway. With legacy systems, they're good, they're reliable, but if they're going to be as performant, and so, and that's what we're testing now. We have a trial in July in Las Vegas, and 1 year for before September. Actual function testing in the field of some small form factor low power systems.
A very specific use case, and you're quoting very specific power and size requirements. Is this consortium building ecosystem? And that happens to be an example of ecosystem, or is that like this consortium is building that with it?
Yeah, so that region has 3 different computer manufacturers, radio manufacturers, different AI. So it's not a wish we're trying to force into your use case. We talk about dust and I joke I did the air force 5 years ago from the toilet disposable. Balance here, those leaders behind us around 35 one. Sorry. So it's deployable uniform sensing technology, it's disposable, right? So throw it out in the battlefield, tens of thousands of them, pre-deployment. Don't recover them. Don't waste, don't miss life to recover these Raspberry Pis. That kind of concept. That's just a platform, not a product. Like it's not a hardware company. Contec is aggregating multiple components from Supermicro, from Memory X, and building this. Trying to limit the number of components. Storage, those mechanisms, so we can stock in volume and aggregate. This just allows for lower cost without forcing you into a single stack. So if you want to go with payroll, great. Great. Memory X, great.
It's a very specific model solution for battery powered image analysis, not a very low data rate, but extremely small, like wearable, small, or smaller than that.
We're working on that. The power is the issue for us. We know that we can do it in FPGA and some of these like extremely small, like for phone base. Can we do 60 frames per second? No. Can we do 12 to say 18, 20 frames per second in 2K with a range in that 100 meters? That's the case. The optics are not big enough. So we leverage the existing battery technology there in phones and place as a package to a phone as a module. Yeah, we can do that. We are working on some wearable system partners. We've already been body worn sensing for stress, heart rate, temperature, pilots, and people like that. And we have packaging partners as well. They're working on yeah, with this screen and part. We have pieces of that stack being worked on. all these things, the answer is yes, the customer says, I have a budget, here's the mission. Right? We're not Samsung, we can't just throw things out and let it down. But
But I will just say that if you, Kevin mentioned this, but to emphasize the point, we've been able to be somewhat picky with the hardware partners that we're bringing in with AI accelerators that can tackle low power, battery powered solutions with maybe not, extreme 60 frames per second, 4K video processing, but something on the ballpark of 10 frames per second at 2K, but with the low power, hyper portable AI accelerator. So we've very intentionally brought in the groups that are innovating to bring the power and compute down and the AI to run on that down as small as possible.
I'm the technology guy, I'm not a sales person, but I spend half of my day talking to technology companies. Right. I found that that's the only thing that takes my ability. They need a product they want to develop. You found something that you want to be brought to market. This is something that I think everybody needs to understand. A consortium. Our job is to make a small bit, find an innovative company that's doing something special. Become part of the group, right? So if someone had the chipset, a chiplet, or an AI accelerator, an FPGA component that we could use to solve that problem, we want to bring them in because that's where the Contec comes in. We bring in the chip, build rest of the hardware stack around them, bring in the software, and go find a market for the product. Jobs to solve problems for our customers. We're not building compute and that hoping it sells. We're actually what we're doing is spare the customer. Many customers from a common stack, but that stack is going to be changing all the time. It's not going to be that in here, right? So I hope that explains things. We love them. Any knowledge you guys want to share with us on people, we should talk.
Any other questions?
I'm really itching to say that.
Okay.
So if you look up here, if you look up here, you'll see a lot of the devices, right? It's just examples, right? Supermicro's up here, an 8U server that's got like 24 H100 GPUs inside, a lot of power. This isn't a modular edge data center kind of solution. You can put side of the road, right? Or a campus. This one right here is a little bit smaller. You can put it on a pole, L4 GPU. And then these other smaller devices that are very specific. The Dust platform, I kind of taught me about it. A piece of it is this little tiny thing right here. Consider all these applications. I mean, we think about the far edge of the web, right? How do you take care of first, right? The edge without power, without cloud. How do you solve that problem? And then work your way in, right? Vantiq enables us to lay a hardware, software, data foundation upon which we can then start to stack, more robust systems, but when it makes sense, right? How about that? Your question about marketplace, all we're focused on is market model. V2X, right? Public safety, emergency response. You're thinking about those ecosystems, who comes in, who's the right partners for these guys. We've got solutions that are already ready, right? That we can show today. We're just doing things innovative. And then chipset, I'm looking at a lot of chipsets right now. And I've got that. Yeah, maybe the conversation going, Kevin, we can talk about it.
Yeah, scared to talk.
Yeah, I heard you mention about using generative AI for public safety messaging, but it got me a little worried because there's really no way to guarantee that this message is going to say what you think it's going to say. So I'm thinking about amplifying misinformation, for example, or there's no good research into how to stop those types of this information.
You're exactly right that that is something that needs to be addressed, right? You can't have a system where it's not deterministic what it's going to say at any point in time, and it could just start running. It's completely wrong. So there are certain things that both the industry as a whole is doing, and then we're specifically doing to address that. As a whole, the process I talked about a little bit earlier, the retrieval augmented generation, RAG. One of the things that do is you're able to tell a large language model, pull from this data and only answer based on this data. Don't answer based on what you were trained on or what you think is just, a probabilistic answer to the question. So you can actually create pretty strict bounds of saying, based on this data that exists outside of the large language model, only answer if the answer is in here. If it's not, then say you don't have an answer to that. Bounding logic by doing that approach. Something that we're doing, we actually have a patent on this, is the ability to combine multiple large language models into a convergence or a consensus algorithm and be able to get a much higher threshold or guarantee around trustworthiness by removing any possible outlier answers, right? And that same large language model, but oftentimes it's actually different large language models with maybe subset or different pieces of the full picture. And we're doing this in the defense space. We have some interesting projects where they effectively want to build like a Jarvis of military intelligence that's integrating into field personnel in the battlefield, right? And so they need to be able to have that communication layer, but it's highly trusted and robust. If you give them bad information, then it's worse than nothing, right? And so how can you make it where these systems are only telling that the individual information that it knows definitively? And sometimes you might not even need generative AI, right? Like generative AI is really good making a conversational layer that feels and talks like a human does. But oftentimes there's things that you can just say, hey, here's what the sensor says, and this is what this means, because we know that automatically. There will be times when you want to get more information from generative AI, and you can do kind of tricks around limiting what information is pulling from, or using multiple that are converging on the answer. But it is an ongoing question for sure. And no doubt, like these systems are going to be a lot of testing to verify that they can't misbehave, so to speak.
It's interesting you said that. The general rule and the guidelines and the policies being set down in the public safety world, especially law enforcement, is that AI is a tool. The AI assisted technology, these are tools. They can be abused, they can be misused, they can be misinterpreted. When it comes to the language, right, the interpretation of that, it's not exact, of course, it's a tool. I saw a demo last week from a company I know really well. They're called Axon. They're out of Scottsdale, and they are the leaders in digital evidence management and body cameras for police. They came out with an AI assisted solution recently, just in the last, well, they just announced it in the last month, where it's a report writing AI tool that is based, one of the big problems, let me back up for a second. One of the big problems in police work, my officers, when I was an officer on the street, I was overwhelmed with trying to complete my police reports. Get those things written, but I've already had, 12 calls for service through the night. I haven't written my, and now I got to go sit down at 3 in the morning, 4 in the morning, and write. But in the, you got some notes, and it's like, oh, so the system they have now, and it's being deployed, it's going to be tested, it's in pilots, different departments, is the body camera, the audio of the body camera and the video will see and hear everything the police officer is supposed to hear, and then some, right? It picks up everything that in the visual field, it hears everything in the within roughly a shot. And at the end of the call, that data is immediately transcribed into a police report. As if, the AI is the officer writing the report. This is Officer Jones, it knows it's Officer Jones, okay. And it spits out a report. Now, at the end of the day, that officer cannot submit that report. Because it's not going to be accurate, right? It's gonna have some gaps, and the officer has to edit that report, but it speeds up the process of that officer's, at that first, it's a force multiplier. So at the end of the night, the officers can go over every transcribed report. And it will say, oh, and I saw this, and I saw a red Chevy with this license plate nearby us, it has everything. And then that's the key, is it has to be a tool, it's not absolute. So that's something I like to tell everybody now, that it's a tool, and this should be really interesting, because that will save a lot of personnel time down the road.
A key part of that is we're not saying that everything is all of a sudden going to be automated by AI, right? AI is an assistant to the humans involved in their understanding of what's going on and their ability to track it, to report against it, and to kind of integrate decision making with AI, but not automating it. And so when you're saying that it's really on the human, then you're just trying to give them the right information to make the best decision possible.
What's the largest amount of sensors that you pull together?
Yeah, the question was, what is the largest amount of sensors that we pull together? So we have a number of projects that we've been doing, I would say in the up to 100,000 sensors in real time. But the way that both the Vantiq platform and this approach is architected, it's effectively infinitely scalable, because the more sensors you have, just more edge computers or more aggregate locations that you do the processing and throw in the. So there's no upper limit in theory to how many sensors or AI systems or different integration points that we can pull in. It's just a matter of how much compute is needed to support that.
Taking the last 2 years, 2 years to try and complete and they fail, right? How are you?
Yeah, the question was, what about the challenges time to market? This is very near to the Vantiq mission. It's not just that these systems can be built, but you need to be able to make it where you can build them in a period of time that's competing with the speed of new technology, new sensors, new AI that's coming out on the market, and the speed with which you can figure out what works, what doesn't, and implement these things quickly enough to show an impact. And so we're looking at basically decreasing the complete design, development, deployment, matching hardware to sensor to intelligence, that the complete program of implementation oftentimes the public safety or disaster response or these systems generally would have been a multi-year project. We're decreasing that by more than an order of magnitude. So in the ballpark of 2 to 6 weeks often. And so we're really looking at creating an approach that we can implement at a level of speed, and it fundamentally changes the go-to-market model of how you can look at it. Try it out.
Okay, well, thank you for our panelists. As I said, it's been a real interesting few weeks getting things together for this exercise. It's been very fast. And into the audience, yeah. So yeah, it's amazing what they're able to do in a very short time. Did I see you there back there? Okay. All right. Well, That's it for tonight, I think. Tomorrow, we will be at the Center for Infrastructure Renewal, which is on the Rellis campus. Check-in is at 8:30. Opening remarks are at 9 o'clock. And we're gonna start promptly, so we don't fall behind things. All right, and like I said, tomorrow afternoon, if you've signed up for the Bush Combat Development Tour, it's pretty neat. We'll get to see some of this stuff that these guys are talking about tomorrow. And then if you're part of the exercise on Thursday, we'll definitely be doing a lot more of that. And we'll show you a variety of things in the DOC while we're doing it. All right, thank you all for coming.